So I wanted to take some time this morning to go over a quick work example that I came across recently that illustrates when and why to use interfaces. At least one option for when and why to use interfaces. Part of the reason I'm making this video is because for some reason, I'm not sure if it's just because I'm not as smart as everybody else that programs in Go, but learning interfaces for me just took a little bit of extra time to grasp. And so I feel like this is an example that would have really helped me as I was kind of wading through that initial learning phase. So let's say that we want to write a piece of software that places orders with several different suppliers. And let's say, so that's the functionality we want. We want to be able to place an order. But let's say supplier one's kind of more primitive. They're not up to speed with technology, and the way you place orders with them is you send an email. And let's say supplier two is a little bit more up to speed, and they have an API we can talk to place an order. So what we have is we have the same core functionality shared between all of our suppliers, supplier one and supplier two, and that is they both can place orders, and we need to place orders with them. But the underlying implementation of how that's actually done is different, i.e., we send an email to one to place an order, we hit an API to place an order with the second one. So those are kind of the differences. This is a perfect example of where we can use interfaces, and so I'm going to illustrate that here. So let's say that let's create a new interface called supplier, and we're going to use this interface to define the behavior that a supplier has to have to be considered a supplier, i.e., we want to have all our suppliers have to have this place order method. The underlying implementation of this place order can change depending on what supplier it is. We're just saying that in order for it to be considered a supplier, you need to have this method. So let's go ahead and create some suppliers. Let's say we have supplier one, and we don't really need anything on the struct for now. And we'll say supplier two. So now we have two suppliers. Let's implement this place order for each of them. So I'm just going to, normally I would do all my types together in my methods separately, but I'm going to do them side by side. So we'll say supplier one, and we'll say place order. Okay. So you can see this little arrow. This is only because I'm using the Golang IDE. This is showing that this particular method and its interface right here both implement the supplier interface because we put the place order method as a method that supplier one has. So let's say we have some custom functionality, custom email order placing functionality. And then we're going to go ahead and just print out sent email to place order. That way we can see that it is in fact calling this particular underlying implementation of supplier one. So let's go ahead and do the same thing with supplier two. I'm just going to copy, I'm going to copy this down. Oh my gosh, I'm missing my keys this morning. Okay, and for this one I'm going to say sent API request to place order. Custom API request order placing functionality. There we go. So what we have now is we have two suppliers who have totally different implementations of the place order function, but they're both considered compatible with this interface, which means that we can, whoa, geez, all right. It's like the fourth time we've done that now, which means that we can utilize both suppliers in kind of a uniform way without worrying about the underlying implementation. So let's just test this out in one easy way. Let's create a supplier one, and this is going to be the actual instance of supplier one. And let's go ahead and create supplier two, which is going to be an actual instance of supplier two. And then let's go ahead and place an order with both of them. Supplier two dot place order. And let's go ahead and run that. So there we go. Two logs, one says sent email to place order, sent API request to place order. So now we know that it's working. This doesn't really do us any good because in this particular case, I could put any method on here, place order 2, for example, and I'll just get rid of this and that. And if I go to supplier 1, I can just call place order 2. So we're not actually really taking advantage of the interface here. So an example of how we could take advantage of the interface is we could make a function called order placer. And order placer, what we could do is we could say, okay, well, it's going to accept a pointer to supplier 1. And then we could pass any supplier 1 to it, like this, or let's do order placer, and then we'll pass in supplier 1. I'm going to get rid of this. And you can see that, oh, yep, it's working. This is fine. But as soon as we try and pass supplier 2 to it, it's going to fail because it's going to say, cannot use supplier 2 as type supplier 1. Even though they both share the same functionality. So how do we get around this? Well, we make a supplier interface that both of them implement, and then functions can accept that interface instead of a specific type. So now we're saying we'll accept any type, struct, int, string, as long as it implements this interface. So now what we can do is we can say, okay, let's just call s supplier, we'll change this to supplier, s dot place order. And you can see, well, I'll go ahead and illustrate this right now. We can go ahead and pass supplier 1 and supplier 2, and when we run them, you can see we get the exact same output. If we want to be really fancy, we can go like this, suppliers, and we can say for supplier equals range suppliers, and we'll just iterate over each supplier calling its place order. What that allows us to do is just kind of shorthand this one. So we're passing 2 different types into the order placer at the same time, and order placer is okay with that because each supplier complies with the supplier's interface. So that's one example that we recently came across in simple form of how you can use an interface to solve a common problem.